In this video, we will learn the relationship between total revenue and output. Okay, let us say we are being given the total revenue function is TR is equal to 100Q minus 2Q square. Q denotes our output, TR denotes the total revenue. Okay, so first let us try to see what exactly is meant by total revenue. Total revenue is simply the price times output. Okay, price times output produced gives us the total revenue. Okay, this will be equal to here 100 q minus 2q square. Okay, so to derive the relationship between total revenue and output, uh, and why the total revenue changes when output changes, first we need to find out the demand function. That's why I have written price into output here in place of total revenue. Okay, now we can do one thing here. If I transpose this q to RHS, it will give get divided to each of these terms. That means our price will be equal to 100q minus 2q square. Okay, transposing, it will get divided to each of these terms. So we have q here, q here. This q and q gets cancelled, and here one q will get cancelled with this q square. So we are left with 100 minus 2q. Okay, and solving for q here. Okay, if I transpose this 2q here, we have 2q is equal to 100 minus p. That means our q will be equal to, again transposing this 2, it will get multiplied to each of these terms. So we have 100 upon 2 minus p upon 2. So our output will be equal to, that means it is 50 minus, so this is 1 upon 2, I can write it as 0.5p. This is our demand function. Okay, now comes the question, uh, why total revenue is zero at a certain level of output. Okay, so for that we need to relate this demand function with this total revenue function. Okay, so let's try to show it here. Let me draw the graph of the demand function first, then I can explain the total revenue function, and it will be very good if we do that very stuff first. So demand function, we have output on the horizontal axis and price on the horizontal axis. This is sorry, on vertical axis. This is our demand function, and you can clearly see there is negative relationship between output and price. That means if price decreases, output will increase, or if price increase, quantity demanded of the output will increase. Okay, and this is being ensured by this minus sign. So if I draw this demand function on this graph, we need only 2 pointers. Okay, to draw the graph. So let me write it here. Let us say when price is equal to 0, when p is equal to 0 in this demand function, our q will be equal to 50 minus 0.5. In place of p, it is 0. That means our output will be equal to 50 only, because 0.5 into 0 is 0. So we have p is equal to 0, q is equal to 50. Okay, let's draw this very stuff here. Let us say this is a point where q is equal to 50. Okay, when q is equal to 50 and price is on this axis, let us say it is 0. This is first point. Another point that we want to draw here is, let me see if I can show it here, because I don't have the unlimited space here. So I need to plot another point in this demand function when output is equal to 0, when q is equal to 0 in this demand function. Okay, if this is 0, that means our 0 is equal to 50 minus 0.5p, which gives us, if I transpose this 0.5p, it will become plus 0.5p is equal to 50. or P is equal to 50 upon 0.5, which comes out to be 50 upon half comes out to be 100. Okay, so we got another 2 pointers, that is when output is equal to 0, price is equal to 50. And let me write it here. So P is equal to 50. Okay, if I draw it on the graph, let us say here we have, and sorry for this mistake, it is 100 here. So corresponding to the price of 100, our quantity demanded is equal to 0, and corresponding to the price of 0, quantity demanded is 50 here. Okay, and we will have a negatively sloped demand curve. Okay, this is our demand curve. Now let's try to figure out the total revenue in relation to this demand curve. Okay, so on this axis we denote our total revenue, and on this axis we have the output. Okay, now as I told you, when price was 0, quantity demanded was 50. Okay, now let's concentrate on this side only. So when price was 0, output was 0. And what is our total revenue function? Let me write it here. So we have total revenue. Total revenue is equal to 100 q minus 2q square. This is the quadratic function here. Now corresponding to the price of 0, our output is also 0. That means total revenue when q is equal to 0. Okay, when q is equal to 0, what will be our total revenue? Just plug the value here. We have 100 into 0 minus 2 into 0 square. Okay, you can see total revenue is equal to, so this is 0, this will also become 0, this is also 0. Okay, since this is a quadratic function and we don't have a constant term here, our graph will pass through the origin, and since the coefficient of our variable in which we have the square, that means coefficient of q square is -2, it will be an inverted shape. I have shown it when quantity is equal to 0, we got total revenue is 0. Let us say this is the point where total revenue is 0 when output is 0. Now what about when quantity was, as I have told, when quantity, rather when price is 0. Okay, as I have told you, when price is 0, output is 50. So corresponding to this, what will be our total revenue? Total revenue when output is equal to 50, just plug q is equal to 50 in our total revenue function. So we have 100 into 50. So we have 100 into 50 minus 2 into 50 square. 2 into 50 square. So this is 100 into 50 comes out to be 5000, minus 50 into 50 is 2500, minus 2500 times 2 comes out to be 5000 again. So total revenue is again equal to 0. Okay, so when output was 50, total revenue is also 0. So corresponding to this, if I draw this point here, so when output was 50, our total revenue was also 0, and the graph of this quadratic function is inverted U-shaped, and it will look like this. Let me see if I have any working color here. Okay, let me show it you with this color. So it will look like this. Okay, this is our total revenue function, that is 100 q minus 2q square. Our total revenue is 0 when we produce 0 units of output, and our total revenue is again 0 when we produce rather when we have 50 units of quantity demanded. And why does this happen? It depends upon the slope of our demand function. Okay, since this is an inverted u-shaped function, okay, it has a perfect symmetry. The highest point on this total revenue function will lie at the middle. That means we have 0, here we have 50, so 50 divided by 2 will give us the middle point on this. That will perfectly be when we have output is equal to 25. Corresponding to the output of 25, our total revenue will be maximum. Okay, so at this point our total revenue will be maximum. Okay, and what will be the total revenue corresponding to this when output is 25? It is as simple. So total revenue when output is equal to q is equal to 25, just plug in the demand function, rather in total revenue function. So we have 100 into 25 minus 2 into 25. So this is 2500. Here we have a square. Okay, so 25 into 25 comes out to be 25 6 to 5, I guess 625 into 2 comes out to be 625. So we have 6 to 5 into 2, this is 2 5s are 10, 2 2s are 4, again 5, 2 6s are 12. So we have 1250, subtracting 1250 from 2500, we will get total revenue of again 1250. That means corresponding to when corresponding to q is equal to 25, our total revenue will be here 2500. Okay, so let me repeat again here. The total revenue, the relationship between total revenue and output depends upon the demand function. Okay, first our total revenue increases, and if I show it on this axis, when our demand function is unit elastic, okay, unit elastic, that means at the middle of the demand function our total revenue is maximum, and to the left of the unit elastic demand function we have elastic demand. Okay, so when we have elastic demand, our total revenue will start increasing. When it reaches to unit elastic, it will be maximum, then our total revenue will start diminishing. Okay, and eventually it will. So this is our inelastic inelastic region. Okay, so the question was why we have total revenue 0 when output is being when quantity demand was 50. It is pretty simple. When the relationship between total revenue, that means the total revenue depends upon the demand function. If we can plot the demand function corresponding to, as I have shown you here, when quantity demanded is 50, the price is equal to 0 here, or when price is equal to 0, quantity demanded is 50. So obviously total revenue will be equal to, we know total revenue is price into output, so at this point our total revenue will be also equal to 0. Okay, I hope I make myself clear. Thank you.